In the previous video, we finished talking about charging by contact and conduction. Now let's talk about the last way to charge objects, and that is through induction. In charging by induction, if a neutral object comes near a charged object, then a slight charge can be induced or created in the neutral object. This creates a polarization effect, where the opposite charges are at opposite ends of the object. Here are some examples. A dust particle floating near a TV or computer screen. Pollution in air cleaners. Painting and coating surfaces, photocopiers, cars. Induction happens in a lot of things that we see every day. Here's another example of charging by induction. We have a Coca-Cola can or a pop can and a balloon. So in this case, in the first figure, we've got a negatively charged balloon, and the negative charge was probably brought about by friction, by rubbing it on to a person's head, for instance, where the electrons were transferred from the head to the balloon. The balloon acts as an insulator, so it takes those electrons. So once those electrons are in the balloon, it is negatively charged. So now it has an excess of negative charges. Because it's an insulator, it doesn't really transfer those electrons, but it will attract other protons. So in this case, the negatively charged balloon induces a movement of electrons within the two pop cans. If you have two pop cans that are placed end to end, and they're placed on a little stand here, when you're moving the stand only, you're going to see that change. So if we have the two pop cans end to end, the pop cans are neutrally charged. We've got the positive protons and the negative electrons, even numbers in the pop cans. So it's a neutral thing, and when you put them end to end, it's still a neutral object. But when you bring the negatively charged balloon towards the pop can, what happens is those positive protons are attracted to the negative electron, the negatively charged balloon. And the electrons, they actually move to the polar end of the object, in this case, the two pop cans. So then you've got one pop can, and this one pop can has all of the negative charges, whereas the pop can to the left has all the positive charges because it's attracted to the negatively charged balloon. So now, the electrons within the pop can objects, they have transferred all the way to pop can B. If we look at the next figure here, we can see that pop can A is still attracted to the negatively charged balloon, and then we have pop can B being negatively charged. So now, once those pop cans are separated, can A has a positive charge and can B has a negative charge. In class, we're going to talk about electrostatic painting of cars and how induction is involved. In all three cases of charging by friction, charging by contact, and charging by induction, only the electrons move. That's really important. That's the staple idea here. Only electrons move. So why do electrons move between objects? Well, in each case, there's a different reason why these electrons are moving. Not only because the electrons are very, very light and very small, and they're the only ones that move, whereas the protons stay put. In the case of friction, charging by friction, the purpose of the electrons moving is to charge an object. So when enough energy is applied to an object, the electrons have the power to jump objects, thus transferring the negativity to an object. In the case of conduct, the purpose of electrons moving is to restore a neutral charge equilibrium in objects. When objects are not neutrally charged, they have a net charge separation or a charge imbalance, just as we saw in that TED Talk video. To restore the objects to neutral state, when objects touch, the electrons will move to balance the charges of each object. As they move quickly, you may feel or see a shock. And in the case of induction, the reason why electrons are moving is to create an induced charge separation. So when objects induce a slight charge in a neutral object, the object then becomes partially